So one of the uses of rational functions for us will be a function called the average cost function. And we use the notation of a bar over the function to say the average. And we say the average cost function is the total cost function divided by how many units you're producing. So let's do some practice using this formula. So we have a taxi driver who has to pay a daily fee of $75, whether he drives at all or not, and a marginal cost of 50 cents per mile. So a cost per mile of 50 cents. So the cost function is going to look like the fixed cost of 75 plus the 50 cents per mile times the number of miles. And that's going to be the total cost. If you drive 100 miles, you would multiply the 100 by the 50 cents to get how much was your total cost for all your mileage. So that's your cost function. So then we're asked to find the average cost function. So we would write C bar of x equals the C function, 75 plus 0.50x over x. So that's our average cost function. Okay, then we're asked to find C bar of 50. So you would read this C bar of 50. It means evaluate that average cost function when x is 50. So everywhere I see an x, I'm going to put a 50. And then go ahead and compute that out. And I'm getting 2. Well, the average cost, let's see, cost was in dollars. And x is miles traveled. So this is going to be in dollars per mile. Okay, whenever you divide by something, then the units become per the units of what you have divided by. So it's $2 per mile. Okay, then it says interpret your answer. So when the taxi driver drives 50 miles, the average cost is $2 per mile. And then if you prefer the notation with a slash, that's fine too. You can say 2 and then the slash also means per and is read per, whichever notation you like. Okay, so then we're asked to find the horizontal asymptote. Well, we were just talking about horizontal asymptotes, and they're what happens as x goes to infinity or gets really, really, really large. So the C bar function looks like 75 plus 0.50x over x. So it's kind of hard to tell exactly what's happening as x gets large when we're just looking at this whole thing. So I would suggest to you that you separate it into two pieces and say this is going to be the limit as x goes to infinity of the 75 over the x plus the 0.50x over the x. And you can see how in the second fraction those x's will cancel. So it's going to be the same limit as 75 over x plus 0.50. Well, as x gets really, 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 really large, when you divide 75 by that x, this ratio is heading towards 0. So as you drive more and more miles, your average cost gets closer and closer to 50 cents per mile, which that makes sense, right? You're taking your $75 daily fee and spreading it out over more and more and more miles. You're dividing by a bigger and bigger number. And another word for x going to infinity is eventually. What happens eventually as you drive more and more miles? Your average cost gets closer and closer to 50 cents per mile. Okay, so we have another similar problem, asks a little bit different questions. So we have the cost of manufacturing a certain mountain bike is given by this formula. So remember, if we do C of 0, that will get the fixed cost. So the 100,000 part is the fixed cost. And the $200 part is the how much per each, where X is how many you're making. Okay, so we're going to use this same formula and write what is C bar of X for this situation. And we'll have 100,000 plus 200X divided by X. And then we're asked to interpret these quantities. So we compute the number and then say, what does that number mean in the context of this problem? So C bar of 1,000 would be plug in 1,000 everywhere you see an X. And let's do that calculation. And I'm getting $300 per bike. So hopefully you're paying attention to the pattern of its per whatever X is representing. So in this case, X is the number of bikes. So per bike. In the previous example, it was per mile. Okay, so then that says when 1,000 bikes are produced, the average cost is $300 per bike. So that's the interpret part. Make sense of the number. Okay, so then let's look at C bar of 10,000. See what happens if they up their production from 1,000 to 10,000. So we're going to put 10,000 everywhere we see an X. And that looks like $210 per bike. So look what happened when you make more, the average cost goes down. Does that match up with your intuition? So when 10,000 bikes are produced, the average cost is $210 per bike. Okay, and then the last question is, well, what's the limit as X goes to 100,000 of C bar of X? So let's see, we're asking what's the limit as X goes to 100,000 of 100,000 plus 200 times, well, first we're going to write it with the X in it because we're finding the limit. And then we're going to try plugging in the number, because if plugging in the number works and gives you an answer, you're done. So I'm going to put 100,000 everywhere I see an X. And I pushed too many buttons too fast. and I'm getting $201 per bike. So hopefully that matches with your intuition, that the more you make, the more your fixed cost is spread out over each bike, and so the average cost will go down. So as production approaches, so that's the limit, 100,000 bikes, the average cost approaches $201 per bike. And so hopefully your intuition is telling you that that gets closer and closer and closer to 200 as we would keep getting a higher and higher production level. And that's all I have for this section. It's a big section. I think this is the biggest one. So after this, they're not quite so long.